Hello friends, welcome in the series of PLL. I am Madan Kumar Jha, and in this lecture series I will explain how to design a classical PLL into Cadence Virtuoso. So for designing a classical PLL into Cadence Virtuoso, we have to design various blocks of PLL. So there are various blocks in a classical PLL, that is phase frequency detector, a charge pump, a loop filter, a VCO, and a divider. So we will design each block in this tutorial, but first in this video I am going to design the PFD, which is phase frequency detector. So I am going to create a new library for this PLL series. So in library I am name it as classical PLL. Okay, and in this lecture series I will do everything into GPTK 45 nanometer technology. So I am going to select GPTK 45, then OK. Now in file I am going to create a cell view into that library, that is classical PLL, and the name of the cell view will be PFD. Okay, so this is the workspace of Cadence Virtuoso. In this workspace I am going to design a PFD. So before designing a PFD I have to design some more component in Cadence Virtuoso. So actually I have taken that series into Cadence tutorial, which is my previous playlist in this YouTube channel. You can go and watch that, but first I am going to explain how to design a PFD into Cadence Virtuoso. So for designing a PFD, I have to design a D flip-flop, a AND gate, uh, and for designing a D flip-flop, that is a resettable D flip-flop, I have to design a NOR gate. So first I will design a NOR gate, then a D flip-flop, then a AND gate. So this component should be designed by me in this lecture series. Okay. So again I am going to my workspace, then I am going to make NOR gate. So again in file, in new, in cell view, its name should be NOR, then OK. So the new workspace will open and I will design NOR gate here, which will be 2 input NOR gate. So for PMOS and NMOS, press I, go to instance, and in GPTK 45, this time I am working on GPTK 45, so always choose GPTK 45 nanometer for PMOS and NMOS. Okay, PMOS, so there will be PMOS 1B, which I should choose. I am not going to change the width. So for designing a NOR gate, I have to take two PMOS into series and two NMOS into parallel. Okay, then press I, search for NMOS and bring it here. Okay, then using W connect this, connect drain and source of NMOS with each other. Then the drain of PM1 should be connected with the source of PM1 should be connected with drain of PM0, and I have to create some pin. So for two input NOR gate I am going to give two input as A and B. So this is the input A, and similarly I have to create one more pin for input, which will be B. Now I am going to connect this B with this and this and A with this. So this is basically a two input NOR gate. Okay, then for BDD and ground I am going to create a pin BDD or BDD, and its direction should be input output type. Then hide this and use here. Similarly for ground I am creating a pin ground, hide this and use it here. Now going to connect the drain of NMOS with ground and the source of NMOS with ground and source of PMOS with BDD. Then body should also be connected with BDD. So I'm going to connect the body of PMOS 1 and PMOS 0 with BDD. Then this should be connected with ground, so I'm going to connect it with drain source because source is already connected with ground. So this is the complete schematic of a NOR gate, but I have to create one output pin also. So press P, go to change the direction with output, and name should be, I'm going to give name Y. Okay, then flip horizontal and use it here. Press W for wiring. So this is the schematic of a two input NOR gate. Then check and save, and I have to create a symbol, because if I will create symbol then I can instantiate every time whenever I required this NOR gate. Okay, so from cell view click on OK. Then the left pin will be A and B, right pin will be Y, top pin should be VDD, and bottom pin should be ground. So I'm going to change this with ground. Okay, you should take care about this, that the uppercase and lowercase sensitive the pin name will be. So if you use the lowercase then there should be lowercase, if you use uppercase then it should be uppercase. Okay, then click on OK. This is the cell view of a NOR gate which is automatically created, but it not like seems good, so I'm going to delete some component and design it accordingly. So I'm going to delete this all using delete button. I want to create a symbol of a NOR gate. So for creating a NOR gate I will use this curve. You have to once click here and here, then you have to subtend an arc. So for that, now after doing this you will click here and then extend it. Okay, then again I will use this arc from here to here. I will use this. Okay, now you can see after clicking twice you should drag it and it look like NOR gate, but it should be more, I think. So now if I will drag it, yeah, this look like a NOR gate. Now I'm going to connect this pin. So this is A, this is B. I'm going to drag it by left press. Okay, this is ground, so use it here. Using R I will rotate this ground, so I'm going to rotate it. Then if you do not want, you can't, you should not do it. It is not mandatory, but for looking good I am going to rotate it. Okay, so this is y, this is output. This is instance name, so whenever you instance it, it will show this name. So I'm going to change this name to nor. Okay, then okay, and I'm going to drag this inside this nor gate. Okay, and one more thing, this is not look like nor gate, it is basically or gate symbol. So one bubble is also required, so press on this, then escape, use this circle. Okay, and drag this. Okay, so now it's look like a NOR gate. I think bubble is more big, so again I'm going to use a short bubble, but I can't use more shorter, I have to use this only. Then connect the output with this and input with this. It is not mandatory to connect this with this all, otherwise it will not, uh, otherwise it will give an error. So it is not given any error, any kind of error, if you will not connect this all, because this is just a symbol, it is not actual circuit of NOR gate. Okay, so you can design any kind of symbol, but for looking good and for your convenience you should design a good symbol. Okay, now I'm going to connect this VDD and ground. So going to connect this VDD with this body and this ground with this. Okay, but it not seems like good. So if I will drag it more forward, then it will connect in a good way. Okay, so this is a symbol of NOR gate. Then go to create, then in selection box click on automatic, so it will automatically create a selection box when you instance this NOR gate. And if you drag any other components in the schematic which will overlap with this selection box, then it will give some error. So for prevent the overlapping and these kind of things, you should use this selection box always. Then click on check and save, and then close this. So your NOR gate schematic have completed. Okay, then close this. Again go to file, and in new you have to create a library. No, cell view, and in cell view you have to make a schematic of a resetable D flip-flop. So I am giving its name as D flip-flop RST. Okay, so press on OK. Then in this workspace I have to design the resetable D flip-flop. This is the schematic of a resetable D flip-flop which is made using NOR gate. Okay, so go to that schematic of D flip-flop RST, and then instance that NOR gate. So in classical PLL library which I have created, you will get that NOR gate. Okay, So this is the NOR gate I've designed. Then click here. I have to use 4. Then again press I. Then rotate it sidewise. So this 4 NOR gate is required for the design of a D flip-flop. Now the output of this NOR gate should be connected with the input of this A terminal. So using wire I am going to connect this. Okay. Then the output of this NOR gate should be connected with the input of this NOR gate. So again press W. Connect this. Here I will give clock signal. So press P and create a pin which is input, and CLK, give its name to CLK, then hide and use it here. Then using W connect this pin. Okay. Now after connection you have to connect the B of this flip-flop NOR gate with the output of the second stage. So I have connected this. Then the input of this should be connected with the output of I, I think I have do something wrong. Its output have connected with this. Then this input is connected with the output. Okay. Then this should be connected with this. Okay. Yeah. So I am going to connect this input A with this, and so this is basically schematic. So you have to take care about this connection. Then the uh, output of this NOR gate should be connected with the input of B of this NOR gate. Then its input should be connected with the output of previous one NOR gate. Okay. Then this will be the input reset. So press P, then create a input pin reset, then flip it horizontally and use here. Then using W connect this. Okay. Now I have designed everything correctly. I have to connect the BDD and ground by creating 2-pin BDD and ground, which will be input output in nature. So press I, then go to press P, then go to direction input output and create a ground. I will use it here. Okay. Similarly I have to create a pin BDD. So press P, then BDD. Now hide and use it here. I will connect all BDD with this and all ground with this. Press F. Okay, for fit screen. Then connect the BDD and ground accordingly. So press W, then connect this BDD with this pin and this BDD also with this wire. Okay, then this BDD also should connect with this, and ground should be connected with this pin. This ground should be connected with this pin. Okay, then the ground of this NOT gate should be connected with this wire, and this should be connected with this wire. Okay, so it's look like everything fine. Then click on check and save. This is a schematic of a disable D flip-flop. Now I am giving this complex schematic to a symbol. So go to create, then uh, create a symbol using cell view. From cell view, then OK. So clock and reset will be our left pin. No, I want to change the reset to bottom. BDD ground will be top pin. Okay, this time. And I think I have missed one pin. There should be one pin which will be output. So close this, press P, create a output pin, and give its name to Q. Okay, then hide this. Okay, and it will be output from the second NOR gate. Okay, so I'm going to use it here. Then press W, connect this with this. Okay, then check and save. Create, go to symbol cell view, then from cell view press OK. Now I want to use this reset pin at bottom, so reset. OK, now going to delete the part name, and in instance name I'm going to change this with D flip-flop. So press Q, then change this instance to DFF. OK, then enter. Now going to change the width of this box, because when I will use it in the real schema, in the whole schematic of a PLL, then at that point I will face problem in connection because it will be large. So I'm going to make it small. Press R to rotate reset. Okay, then D flip-flop should be there, and press R. Okay, I do not want to reset this D flip-flop. Then this ground VDD will be here and ground will be here. Okay, no problem. Then undo, using U you can undo this. Okay, now I'm going to delete this and this. Okay, this will be our Q. So I'm going to press this ground here and this Q here. Okay, using R rotate this ground, and using R rotate this VDD. Okay, so this is VDD and this is clock. So you should design this for a look good looking symbol. So double click here, once click, then connects. At connection point you should double left click. Okay, so this is the schematic of a D flip-flop. Now go to create. In selection box you have to create a selection box automatic, then check and save, and then close this. So this is the schematic of a D flip-flop. So I have made a D flip-flop and a NOR gate schematic. Now I have to make the schematic of a NAND gate also and AND gate also, because you can see here in the schematic of a PFD I have used a two D flip-flop and one AND gate. Okay, so this time I'm going to create a AND gate. So close this again, go to file, then in new, in cell view, uh, I'm going to create AND gate. So for that press I again. For PMOS in GPDK45 you will get PMOS GPDK45. I'm searching for PMOS. So for designing a AND gate, first I have to design a NAND gate, then I have to use an inverter. Okay, so for designing a AND gate I have to connect NAND gate, I have to connect two PMOS in parallel and two NMOS in series. So press I again, then go to symbol, this is NMOS. Okay, and for an inverter I have also used one NMOS and one PMOS. So press PI and type PMOS, then you will get a PMOS here. This is for inverter. Now I have to connect this all using wire. So the PMOS drain should be connected with the drain of a PMOS and the source with source for a two input NAND gate. Okay, and the source of first NMOS NM0 should be connected with the drain of NMOS 1, and the source of NM0 should be connected with this wire. Okay, then I have to use two pin A and B. So okay, I'm creating first a pin Y for output. So going to hide this using R. I'm to going rotate it so it will be output pin. Then two input pin is also required, so change the direction to input, then press A for input pin, go to hide this, then one more input pin which name will be B, hide this. Okay, then using W connect this with this. Actually I am not explaining when I have used escape button and undo button. So when you do not want to, when you want to change if anything will do incorrectly, and if you want to uh, delete that or change that to previous one, you should use undo, and for undo you should use U, press U for undo, and escape button for escaping anything, like I am when I want to use wire, this wire. Okay, and if I want to escape from this wire, so use escape button. Okay, but I do not want the wire here, so again using undo I'm going to delete it. Okay, okay, so again press W and connect this body with this source of PMOS, because this source will be connected with VDD, so automatically this body will connected with that VDD. Similarly Okay, so I am going to create two pin. One is BDD and its direction should be input output. Okay, so this is the BDD pin. So I will connect BDD source of PMOS with BDD. Then again I'm going to create a pin P for NMOS ground, NMOS source, and this pin will be ground. Okay, now connect this BDD with this source and the ground with this source. Okay, press F, connect the body of this NMOS with ground and this NMOS with ground. So connect it with ground. Okay, this is also NMOS, so its source should be connected with ground and body should also be connected with ground. So connect this. Then this is basically inverter, so drain will be connected with the drain and gate will be connected with the gate, and this PMOS source should be connected with the VDD. Okay, actually this is the output of this node will be the this net will be the output of uh, NAND gate, and I want to design an AND gate, so this is the input of an inverter. So connect this with this. Okay, so what signal you will get there will be inverted by this inverter, and the output of this inverter will give you at the AND operation. Okay, so press W, then connect this with this. Okay, now I think everything is correct, so no need to yeah, I have made one mistake, and that is the input B of this PMOS should be connected with the pin B. Okay, so now I think everything is correct. So oh sorry, so check and save, and once I'm going to check either it is correct or not. So schematic check completed with no errors. Then I have to create the symbol of this AND gate also. So go to create, then in cell view, from cell view press OK. Then A, B will be left pin, Y will be OK. So this time I am going to create this ground at bottom. Okay, so this is a symbol of AND gate, but it is automatically created by Cadence, so I'm not going to use this because it do not look like the AND gate, but I want AND gate. Okay, so press this wire, oh sorry, click on this wire, then double click here. Okay, and now I want to use this curve, so again press here and here, then okay, then you can expand it, but it is mismatched. Okay, so now I am going to use this A here. Okay, this time I'm use this A here, B here, Y will be on top of this. Okay, and this will be here. This time since this is a AND gate, so no need to use a bubble in the symbol. Now press R for rotate this ground. Now this ground will be here, then this BTT should be here again. Oh, use U for undo. Okay, I want to drag this BTT here, press R, Then connect the body of this and get with this. Okay, then it should be connected with this, it should be connected to this, it should be connected with this. Okay, then press on instance name, press Q for change the property, then give its name to and. So A and D I'm giving capital. So this is the schematic of a, this is the symbol of a AND gate. Then go to create in selection box, click on automatic, it will generate a automatic selection box, then check and save and close it. Now you have to made a PFD using these all components. So actually I have made the cell view of a PFD. So open that cell view. So this is the PFD, but here nothing is now because now I have to interconnect all those things. So press I, go to library GP, sorry, classical PLL, and in classical PLL you will get everything you have designed now. So press, uh, I want to use the D flip flop, so D flip flop reset will become here. Then use this D flip flop here. Okay, again press I, go to use this D flip flop again, because if you want to, okay, so first click on upside down, then drag it here. Now if you will see this, so two D flip flop and one AND gate should be required. So now I'm going to instance a AND gate. So press I, then click on cell, then type AND, then hide this. Actually I want to flip it horizontal, so escape, press escape, again press I, then flip horizontal. Okay, now I want to connect the output of this AND gate with the reset button, so press W, again create a pin QAP, then QA, which will be output. Okay, so it should be output pin, then use it here. Okay, and one more pin QB, which will be output. So QB, flip horizontal, then use it here. Now press W, then connect this QA with this, QB with this, and QA with this. Okay, and A should be connected with this QA, and B should be connected with QB. Okay, then two more pin will be required, which will be B reference and B divider. So press P, input, it should be input time. For a PFD, reference signal will be required and the feedback signal from divider will be required for the input of this both clocks. So I am going to give this name as Vref and V divide. Okay, then hide this, use here, again press P, then press V div. Okay, then use it here. Okay, then connect this with this and this with this. So this is the schematic. Now for a BDD and ground I have to create two pin more, which will be VDD, input output in nature, and it will be VDD VDD. But before creating the cell view of this PFD, symbol of this PFD, I want to test it. Okay, I'm going to test this PFD, because if I will create a symbol of this PFD, then I have again I have to make a new test file, and in that test file I have to instance this PFD, and then I have to apply the signal to them. So it will be more complex and the video will be lengthier, so I am going to test it now. After that I will create symbol. So press I, go to Peoples, in analog library. Okay, in analog library you will find Peoples, create on this, then change the voltage 1 to 1.8 volt, B2 to 0, or I am going to, or I'm using B0 to 0, B1 to 1.8. Okay, then period I am going to use 20 nanosecond. The pulse width will be 10 nanosecond. Okay, for B reference, then I do not assigning any delay. Then I'm going to hide this, but upside down. Okay, so hide this. The positive of this people should be connected to B reference, so I have rotate it vertically. You should also do this. Then click connect this with the V reference. Okay, then again copy this using C, then rotate this using R. So without pressing you should rotate it, then use here, then using wire you should connect this B divider with this, then press I. In analog library you will get ground, so go to symbol of ground, use it here. Again press R, rotate this ground. Okay, actually I want this ground here also, so copy this, use here, then again copy this, press R and use it here. Okay, now I have to use the BTT also, so press I, then in analog library go to VDC, then set VDC volt. DC voltage should be 1.1 volt for 45 nanometer technology, so I'm going to use it 1.1. Then use this ground, copies using C, then connect with the negative terminal of BDC, then positive terminal will be connected to VDD, so use this VDD, click on symbol, you will get the symbol of a VDD, and use wherever BDD is required, so rotate it using R and use it here also. Okay, so now I have connected everything, but here I have used the same signals, so there will no any phase error in reference and divider. So for creating a phase error I am giving some delay to divider, so click on Q, in properties give a delay time of let's 3 nanosecond or 2 nanosecond I'm assigning. Okay, 2 nano. Okay, then click on OK. Now go to check and save. There will be two warning. Actually I have not connected the BDD of this AND gate and the ground of this AND gate with the BDD and ground, so copy this ground using C, then connect it with this ground, and copy this VDD using C, then connect it with this. Okay, now check and save, so there will be no error. Then go to launch in ADL, click on session, then right click on the analysis, then click on moderate. I'm going to analysis for 200 nanosecond because 20 nanosecond is our period. Then click on OK. Go to outputs, click on edit, then from design copy the input and output. So V reference, B divider, QA and QB. I want to see the output waveform. Okay, then click on OK. Go to setup, check model libraries and unselect every one except GPDK45. Okay, so I have unchecked everyone. Then click on OK, then run. So when you will run this, you will get output. Okay, so this is V reference, this is V divider, this is QA, this is QB. Okay, so since when V reference have come at 0 time, then okay, so then at that time it doesn't sense this. Okay, so it seems that V divider is leading. Okay, so when V divider is leading, then down signal should be high, so the down signal will be high. Okay, and when the V reference will be high, then it will be automatically low. So here if this is leading, then V reference is lagging, so when V reference will be high again, then it will be comes from logic high to logic 0, and at that time one QA pulse will be generated, which is up signal. So it is working good, it is working correct, but here it predict that V reference will be coming here. Okay, not here. So it seems that V divider is leading, but I want to see the output when V reference is leading and V divider is lagging. Here V divider is leading and V reference is lagging in this case, so this output is correct. Now I want to show you what happened when V reference is leading. So for that, again I'm going to change the properties of this signal. I am giving here delay 1 nanosecond. Okay, then I'm going to increase this delay. Press Q, here 4 nanosecond. Okay, then click on check and save, then go to ADL again, run this simulation. Now you will get the output which I have told earlier, I think. So this time V reference is leading and V divider is lagging, but again it do not predict that A is leading. Again it seems that V divider is leading and V reference is lagging, so it generate the signal accordingly. So when V divider is lagging, down signal QB will be high and V reference is when V reference is rising, okay, then it will be 0. Okay, so this is the problem of cadence. Now going to try once more, click on escape, then press Q, change it to 1.8 to 0 and change it from 0 to 1.8. Similarly here also press Q, going to change this to 0 and this to 1.8 and check what happened. Yeah, so this time you got correct. So going to select this all waveform, change the width style to solid and width to medium. Okay, so now you can observe when V reference is leading and V divider is lagging, so it do not conclude this first phase difference, and I don't know why it do not conclude this. Okay, so after one phase error, when in second phase when B reference is 1 rising, then it will the QA will be the up signal will be high, and when B divider will be rising, then Q up signal will be low. So when V reference is leading from B divider, up signal will be generated for that time, and when it will be falling, then down signal will be high for a certain time. So this is the characteristics of a PFD. So PFD is working in this way. So I will use this block PFD in my PLL block diagram when I will completely see the schematic of a PLL and when I will run that. Okay, now it is working correct. So I'm going to close this simulation, then close this. So save this state. If you will save it, you can open ADL whenever you will required without copying that output signal and without setting that transient time. Okay, now delete this. Okay, now I'm going to create the symbol of this PFD. So I will use pin instead of this VDD and ground. So press P, then create a pin VDD. So this will be VDD, then hide this, use it here, again press P, then GND for ground, use this here. Okay, now connect the VDD with this. So press W, connect it with this, and this VDD with this. Okay, similarly the ground should be connected with this, and this ground should be connected with this pin. Okay, now everything is correct. Click on check and save. There is two warning. Okay, the ground of this and gate should be connected with the ground of this. Okay, similarly the ground VDD should be connected with this VDD pin. Okay, now check and save, then go to create and in cell view, from cell view click on OK, then V divider, V reference, QA, QV, VDD ground. So going to use this ground at bottom pins, so use it ground, then click on OK. This is the symbol for PFD. Going to delete this part name. For instance name I am going to change its name to PFD, then enter. So this will be PFD. Going to make it smaller. Now use this B divider here, B reference here, and make it more smaller. Okay, then delete this, this, and this all. Again connect this with this. Similarly Q and QB should be here. Okay, then use this BTT here. The ground should be here. Press R, then copy this ground. So if you are a beginner, you will face some problem in creating a symbol and these all things, but I will tell you. Go to my previous page and check how to create a symbol, how to use this, how to use the shortcut keys. Okay, you will be comfortable after seeing that videos. So watch that video twice if you will not understand anything. Oh sorry, use U for undo, then delete this also. Make it more closer, because if it will be more closer it will take less area into the schematic symbol page, a schematic of a PLL. So actually a PLL have very much component, so if it will be in lesser area then it will be visible clearly, otherwise it will be, the whole PLL will not looks like good. Okay, so for some accuracy you have to spend some time. Then go to create in selection box, click on automatic, then check and save this PFD. Okay, so this the uh, symbol of PFD. So you can see how I have created a symbol of PFD. So in upcoming videos when I will create the symbol of charge pump, similarly a BCU, a divider, after that I will use this PFD and those all components and then log that PLL in upcoming video. So thank you for watching this video.